Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 8. Given two coplanar and concentric loops 1 and 2 as shown in the figure, a time-varying voltage. So a time-varying voltage V as a function of t, it is applied to the outer loop and the value for that is 3 plus 2t as a function of time. And the resistance for loop 1, it is 10 ohm, and for the inner loop, loop 2, it is 1 ohm. We need to find the current induced in the loop 2 because of the current that is flowing in the outer loop. There will be a magnetic field, and that magnetic field will pass through the inner loop, and due to that there will be change in flux, and that change in flux will lead to the generation of the induced current in loop 2. So first find out the magnetic field due to current in loop 1. So we can see that the voltage is given to us as a function of time. So the current will also be a function of time, and it will be voltage divided by the resistance of loop 1, and it will be equal to 3 plus 2t divided by 10. So this is the value of current, and we need to find the magnetic field because of this current. So it will be V1 is equal to mu naught I as a function of t divided by 2 into radius of the outer loop, and it is p. So the radius of the outer loop is p, and it is 1 meter. So we can write it as mu naught, and in place of I is a function of t, we can write 3 plus 2t divided by 10, and 2 into p was already there in the formula, and p was equal to 1 meter. So we can again write it as mu naught 3 plus 2t divided by 20. So this is the magnetic field because of the current that is flowing in the outer loop, and these magnetic field lines will pass through the inner loop, and they will create the flux. So flux associated with inner loop, that is phi 2, it will be number of turns time the magnetic field B1 multiplied by area of the loop. Since there is no information given on the number of turns, we will consider it as 1 only. So it will be B1 multiplied by A2, and B1 is mu naught 3 plus 2t divided by 20 multiplied by area of the inner loop, and area of inner loop, it will be pi into q square, where q is the radius of the inner loop, and it is 0.1 meter. So we can write it as mu naught 3 plus 2t multiplied by pi multiplied by 10 to the power minus 2 upon 20. So this is the value of the flux associated with the inner loop. We can further simplify it as phi 2 is equal to mu naught times 3 plus 2t pi divided by 2000, because this 10 to the power minus 2, I have taken it in the denominator. So this is the flux. Now we have to find the EMF induced in the loop 2. So that will be equal to E is equal to minus d upon dt of phi 2. So that will be minus d upon dt of mu naught into 3 plus 2t multiplied by pi divided by 2000. So we can see mu naught is a constant, pi is a constant, and 2000 is also a constant. That bit can be taken out of the differentiation. So it will be minus mu naught pi divided by 2000 multiplied by d upon dt of 3 plus 2t. And we know the differentiation of 3, it's a constant, it will be 0, and differentiation of 2t will be 2. So finally we can write E is equal to minus mu naught pi divided by 2000 multiplied by 2. So this 2 will cancel this 2000, and it will be minus mu naught pi upon 1000. So this is the value of EMF generated in loop 2. Now in order to find the value of induced current, we have to divide EMF with the resistance of loop 2. And the resistance of loop 2 is 1 ohm. So further, we can write induced current in loop 2, it will be the EMF generated in loop 2 divided by the resistance of loop 2. So this is the value of the induced current. So let's take the value of E that we have calculated in the first case, that is minus mu naught pi divided by 1000. So minus mu naught pi divided by 1000, and again R2 value is given to us as 1 ohm. So it will be 1 only. So the value of induced current will be same to that of the induced EMF because the resistance was 1 ohm only. So it will be I is equal to minus mu naught pi divided by 1000 amperes. This is the final answer. And if we want magnitude of current, then it will be I is equal to mu naught pi divided by 1000. This minus sign tells us that this induced current is in such a way that it will oppose the cause of its production. That is the Lenz's law. Thank you. Keep learning, keep practicing, keep excelling.